Hello students, welcome to Educate. In this video, we will discuss about variation of conductivity and molar conductivity of electrolyte. Variation of conductivity and molar conductivity of electrolytic solution with concentration. That means what will be the relationship between conductivity as well as molar conductivity with concentration of electrolytic solution. That means if you will dilute the solution or if we will concentrate the solution, then what will be the effect on the conductivity and molar conductivity we will discuss in this topic. Okay, first of all, what will be effect on diluting the solution on the conductivity? That means when we dilute the solutions, then what will be the effect on the conductivity? So let's see, when we will dilute the solution, then number of ions per unit volume, then the number of ions per unit volume will decrease. So conductivity will decrease, because for the conductivity ions are responsible and the number of ions per unit volume will decrease. So on diluting the solution, the conductivity will decrease. So that means there is a direct relationship between conductivity will be directly proportional to concentration. That is, in generalized way, you can consider this one. That means if the concentration of the solution will increase, then conductivity will increase. But the molar conductivity, that means molar conductivity, here kappa or you may write lambda, that is for conductivity, lambda for conductivity, and lambda m, that is molar conductivity. That here, on diluting the solution, the conductivity will increase. That means on diluting the solution, the conductivity will increase because volume of the solution will increase. On diluting the solution, the molar conductivity will increase. So here both is opposite. So here, what about the relationship? 1 upon, there is under root C. About that you will study in case of a strong electrolyte and in case of weak electrolyte, that will be different. So here it is for a strong electrolyte, same relationship for weak electrolyte. So you may say that on diluting the solution, the conductivity will decrease while the molar conductivity will increase. That is, here on diluting the solution, keep in the mind, on diluting the solution, the conductivity of electrolytic solution will decrease. On diluting the solution, the conductivity of electrolytic solution will decrease. Why? Because number of ions per unit volume will decrease, while the molar conductivity that is can be represented by lambda m. Here simply conductivity means lambda, while the molar conductivity will increase okay, that is here. So that's the relationship you keep in the mind. That is important for your IIT main examination, for your NEET examination, as well as for your 12th board examination. This point you keep in the mind. That is, on diluting the solution, the conductivity which is represented by lambda, the conductivity of electrolytic solutions will decrease while the molar conductivity will increase. Okay, so how about that one we will discuss in detail. Let's see. Just watch out this graph. Here the graph is. This is for a strong electrolyte, KCl. First of all, what is a strong electrolyte? Might be you know. A strong electrolyte means the electrolyte which dissociate completely when dissolved in water. The substance which dissociate completely when dissolved in water, that is called a strong electrolyte. And the weak electrolyte are the substance which do not dissociate completely when dissolved in water. Okay, so let's see firstly consider about the conductivity of a strong electrolyte. Here a plot of the molar conductivity, versus root under C, that means concentration. That means molar conductivity with respect to under root C, not directly proportional. That's a graph of the molar conductivity, versus under root C has been plotted, this graph. So for a strong electrolyte, watch out here, this graph is just decreasing graph here. This for molar conductivity, this graph is decreasing. So what happened here, this intercept will be equal to, here lambda m equal to, this intercept will be here lambda degree m, limiting molar conductivity. Limiting molar conductivity means molar conductivity at infinite dilution. As you know, on diluting the solution, the molar conductivity increases. On diluting the solution, the molar conductivity increases. So at infinite dilution, the molar conductivity will be maximum. So lambda degree m may be also considered as the maximum molar conductivity. So here, this one, for a strong electrolyte, the relationship between molar conductivity and that of the concentration is lambda m, that equal to lambda degree m minus a root c. C to the power half means a root c. So lambda m equal to lambda degree m minus a root c. So for this graph, lambda m and under root c, that will be a straight line, graph, and here that will be a decreasing graph, and lambda degree m will be maximum value, and so lambda degree m, that will be the intercept, and a will be the slope. So that's a graph here. So this graph here, that is lambda degree m, and here this is intercept. Intercept will be lambda degree m, and slope will be here minus a. This slope, this upon this, that means the slope will be, for this one, slope will be a minus a, that means decreasing graph here. Okay, so that is the relationship of when you are diluting the solution. So constant under root c will decrease. So if you push in this graph from right to left, so concentric under root c is decreasing. That means concentration is also decreasing. So conductivity will increase. That means on diluting the solution, the molar conductivity of a strong electrolyte will increase, and on increasing the concentration, the molar conductivity of a strong electrolyte, on increasing the concentration, the molar conductivity of a strong electrolyte will increase, and the relationship will be lambda m will be equal to lambda degree m minus a root c. Lambda m equal to lambda degree m minus E under root C. C to the power half is, that means under root C. I hope no problem here in this topic. And yes, about the weak electrolyte, what happened here? Firstly, for weak electrolyte, what is here? That was for a strong electrolyte, and for weak electrolyte, what is here? Alpha is lambda m upon lambda degree m. Alpha is degree of dissociation. Suppose for the acetic acid here, so about that we are taking acetic acid, CH3COOH. When that will dissolve in water, so what happened? Acetic acid will lose one H plus ion, there will be a formation of H3O plus, and one negative charge will appear on this oxygen atom. So compound will be CH3CO minus acetate ion and H3O plus. Okay, at T equal to 0. Suppose concentration of acetic acid will be C. So at that time, the concentration of acetate ion will be 0, and that of hydronium ion will be also 0. That is when equilibrium will attain. Then its concentration will be C into 1 minus alpha. How's that? Let's see. Alpha here is degree of dissociation. Degree of dissociation means when the concentration of this one, when the concentration of any acid or base or any electrolyte, when the concentration of electrolyte is 1, then how much electrolyte will dissociate? That will be called degree of dissociation. Degree of dissociation means the number of electrolyte dissociated when the concentration of electrolyte will be 1 molar. Degree of dissociation is the number of electrolyte dissociated when the concentration of electrolyte will be 1 molar. Any problem? So you may write also degree of dissociation is degree of, in the 12th board examination, this one will not ask you examination. In IIT main and advanced, I am here writing here so that who will prepare for IIT main or for the NEET examination, this concept will be too much helpful for those guys. So let's see. Degree of dissociation is the concentration of electrolyte dissociated when 1 molar Okay, so now when 1 molar solution has been taken, then alpha will get dissociate. So when C molar solution electrolyte will be taken, then C alpha will dissociate. When 1 molar of electrolyte will be taken, then alpha will dissociate. So when C molar electrolyte will be taken, then C alpha will dissociate. So undissociated electrolyte, so will be how much? C was previously and C alpha has been dissociated, so that will be C minus C alpha, that will be equal to C will be taken common and 1 minus alpha. C alpha has been dissociated, you have to consider there. So when concentration of C, so 1 mole give 1 mole of acetate ion. So C alpha of, when C alpha of acetic acid will dissociate, then the acetate ion formed will be C alpha. When 1 mole of acetic acid will be taken, then alpha mole of acetate ion will form. When 1 mole acetic acid will be taken, then alpha mole of acetate ion will form and alpha mole of hydronium ion will form. So, if C mole of acetic acid will be taken, then C alpha of acetate ion and C alpha of hydronium ion will form. So, hydronium ion will be also C alpha. That is here. I hope there is no any problem. So, Ka, dissociation constant, that will be equal to concentration of acetate ion into concentration of hydronium ion, that upon concentration of acetic acid. And here also I have told you alpha is equal to lambda m upon lambda degree m. So put the value of alpha as lambda m upon lambda degree m. So what will be here? So here Ka will be equal to C into lambda m upon lambda degree m. That's a square, that whole upon 1 minus lambda m upon lambda degree m. I think no any problem here. K will be equal to C alpha square upon 1 minus alpha here. Alpha, the value of alpha I have put it. So Ka will be equal to that means here lambda degree m and lambda degree m, that can be cancelled out. So Ka will be equal to C lambda m, that's a square, upon lambda degree m. Just a moment here. This one, so lambda degree m also. Lambda m upon lambda degree m, C lambda m, that's a square, upon lambda degree m, that's a square, into lambda degree m gone into numerator. So here lambda degree m. So lambda degree m and this one cancel out. So here will be lambda degree m will left into lambda degree m minus lambda m. C lambda m, that's a square. C lambda m, that's a square, upon lambda degree m into lambda degree m minus lambda m. That is the relationship. So Ka will be that. And what is happening here? For the weak electrolyte here, as you dilute the solutions, diluting the solutions, so conductivity is decreasing. On diluting the solution, conductivity is decreasing, and then after approaches to this side. So as you move from right to left, so that means on decreasing the concentration, the conductivity will increase. So that is indicating that for a strong electrolyte as well as for weak electrolyte, on diluting the solution, the molar conductivity will increase. On diluting the solution, the molar conductivity will increase, or on increasing the concentration, the molar conductivity will decrease. Okay guys, so that was here. Now let's see. This question here, molar conductivity of KCl solution at different concentration, this one. So what here, concentration has been given and molar conductivity has been given, and you will have to plot the graph of lambda m and lambda and root under C. So what's the problem here? Take the square root of this one and lambda m. Take a graph here, this one, here lambda m you take, and in this side here will be lambda m, and here under root c. Firstly, you will have to calculate this under root c will be how much, and then after plot the graph, and you will find out that, oh sorry, then you will find out that on diluting the solution, the concentration is increasing. That means with respect to concentration, here C. So on decreasing this concept, this one is for KCl. So it is a strong electrolyte. So that will be a straight line graph, and like this one, and by this graph you can also find out the limiting molar conductivity. So plot the graph, and when you will touch this one to the y-axis, when you will touch the graph at the y-axis, you will get limiting molar conductivity, means lambda degree m you will get. Okay, very easy question it is. Take the graph paper, and then after plot them. Very easy. Take the under by taking the root under C. So this question is very easy. Then after is Cole-Rawls law. Yes, in the examination of 12th board, the Cole-Rawls law frequently asked. In the 12th board examination, Cole-Rawls law frequently asked, and for IIT main examination and NEET examination, there will be utility of this Cole-Rawls law. What Cole-Rawls law tell? Suppose you have taken the conductivity of NaCl. So that means here conductivity of molar conductivity of NaCl. So that will be equal to molar conductivity of Na plus and molar conductivity of Cl minus. Because NaCl, that will dissociate into Na plus and Cl minus. So molar conductivity of NaCl will be Na plus and that of Cl minus. That means the Cole-Rawls law states that the molar conductivity of, or limiting molar conductivity of, so limiting molar conductivity means the conductivity of electrolyte at infinite dilution. Limiting molar conductivity means the conductivity of the electrolyte at infinite dilution. So Cole-Rawls law states that the limiting molar conductivity of a strong electrolyte will be equal to the summation of the limiting molar conductivity of cation and anion obtained from that electrolyte. And for weak electrolyte also, the limiting molar conductivity will be equal to how much ions will be there. So that means summation of the molar conductivity of cation and anion both. So that is here this case. So this law states that limiting molar conductivity of an electrolyte can be represented as sum of individual contributions of this one and this one. Okay, that is called law of independent migration of ions. That means you may also say that the limiting molar conductivity of any ion will not depend on the electrolyte from which that ion has been obtained. The limiting molar conductivity of any ion, that is either cation or anion, will not depend on the electrolyte from which that ions has been taken. Okay, that was here. For weak electrolyte, I have also calculated this one. Here lambda, this one I have already calculated previously. You may refer there. That was. Now, very important here is this question. Calculate lambda degree m for CaCl2 and MgSO4. So, to calculate the limiting molar conductivity of CaCl2, you will have to find out the limiting molar conductivity of calcium ion and that of chloride ion. That means here, let's see, CaCl2, that will dissociate into Ca2 plus and 2 moles of Cl minus. So what will happen? The limiting molar conductivity of CaCl2, that will be equal to the limiting molar conductivity of Ca2 plus 2 into limiting molar conductivity of Cl minus. That is same, the limiting molar conductivity of MgSO4, that will be equal to the limiting molar conductivity of Mg2 plus the limiting molar conductivity of SO4 2 minus. So you will have to find out the limiting molar conductivity of calcium, chloride, magnesium and SO4. So table 3.2. So let's see about where is table 3.2. So let's see here. Table 3.2 here given. So for magnesium it is 106.0. So watch out that 100 magnesium, calcium, sulfate and chloride already given here. You calculate that value here by taking the data from here. Very easily you will get what's the limiting molar conductivity of CaCl2. That means the limiting molar conductivity of, here you can find out the limiting molar conductivity of CaCl2, that will be equal to here. So calcium here how much? 119. So 119 plus 2 into Cl minus is here how much? 76.3. 76.3. So what will be there? That much the limiting molar conductivity of CaCl2. Same as the limiting molar conductivity of MgSO4, that will be equal to magnesium here 106. So that will be 106. What is that here? Siemens centimeter square per mole. What is that? And sulfate ion here 160. So 160. That much Siemens centimeter square per mole. That you can find out here also, Siemens centimeter square per mole. Very easily. So very easily you could calculate this question. Now let's see on this question. And this question is very important, particularly for NEET examination and for IIT main. For IIT advanced, this question directly don't ask, but the importance of this question should not be denied for the IIT advanced. But this is important, more important for IIT main and IIT and the NEET examination. But its importance should not be denied for IIT advanced. And this question also asked in the 12th board examination, not oftenly as it is asked in IIT main and in NEET examination. So but there is this type of question has been asked also in 12th board examination. So we should not ignore this question. Let's see to solve this question. What is here? The limiting molar conductivity of NaCl, HCl and sodium acetate. NaAC, actually it is CS3COONa. It is sodium. This one is acetate ion. Acetate ion, so that's why in short that has been written as AC. So sodium, NaCl, HCl and sodium acetate has been given. So you will have to find out the limiting molar conductivity of acetic acid. That means of this compound, you will have to find out the limiting molar conductivity. Okay, just think for 1 minute. I am telling you. What is here? Acetic acid is a weak electrolyte. So it will not dissociate completely in water. If it would be a strong electrolyte, then simply you will tell that the limiting molar conductivity of acetic acid would be equal to the limiting molar conductivity of acetate ion and that of H plus ion. But the acetic acid don't dissociate completely in water. That is, it is a weak electrolyte. So we will have to consider by this one. So let's see here. How's that? Acetic acid here. So when there will be dissociation of acetic acid, there will be formation of acetate ion and H plus ion. Among this one, which one is from where you can get acetate ion? So from sodium acetate you can get the acetate ion. So here that is this one. So sodium acetate here. So that will dissociate to CH3COO minus and Na plus. So acetate as ion value will take sodium acetate, then you will have the acetate ion and sodium ion also. So here sodium ion you got extra. So from where you can get sodium? Sodium you can get from here. So here is plus. So take minus. So NaCl will dissociate to Na plus and Cl minus. So when you will subtract the NaCl, so that will be minus Na plus and minus Cl minus. Now Cl minus is in negative. So cancel out by taking HCl. So when you will take HCl, so plus H plus and Cl minus. So Na plus, this one get cancel out, this one will get cancel out. That means finally you will get acetate ion and the H plus ion. That means what's your desired equation that you can get by taking the sodium acetate, that of minus NaCl and that of HCl. That means the limiting molar conductivity of acetic acid, that means HAC, that will be equal to the limiting molar conductivity of sodium acetate. So limiting molar conductivity of sodium acetate, that minus limiting molar conductivity of NaCl, and that plus the limiting molar conductivity of HCl. So limiting molar conductivity of acetic acid will be equal to the limiting molar conductivity of sodium acetate. Sodium acetate 91.0. So limiting molar conductivity of acetic acid, that will be equal to sodium acetate here given how much? 91.0. So 91.0 Siemens centimeter square per mole. Then after of sodium chloride here 126.4. So that is minus. So minus 126.4 Siemens centimeter square per mole. And plus is limiting molar conductivity of HCl. So limiting molar conductivity of HCl has been given how much? HCl has been given 425.9. So plus 425.9 Siemens centimeter square per mole. Calculate this one and finally you will get 390.5 Siemens centimeter square per mole. Watch out. Is it clear or not for you? Watch out, the next question 2.9. I think this one is clear for you. Now there is concentration has been given of acetic acid and conductivity has been given. Conductivity has been given, concentration has been given, conductivity has been given in Siemens per centimeter and concentration has been given mole per liter. Calculate dissociation constant of if lambda degree for acetic acid, that means limiting molar conductivity has been given. So Ka is asking. Very easy it is. So what is here? conductivity is 9.5 into 10 power minus 5 Simon per centimeter. So listen here, conductivity has been given in this one and concentration is in mole per liter. That means conductivity has been given in mole per decimeter cube. Mole per decimeter cube. So concentration you will have to find out in mole per milliliter. Mole per milliliter. That you will have to find out concentration. So concentration of solution, that is equal to 0.001028 mole per liter. So in milliliter, suppose in 1 liter, how much number of moles is there? 0.001028. That much mole of electrolyte is there. Number of moles in 1 liter is that much. Centimeter. So that means in 1 milliliter, number of moles will be how much? That into 10 power 3. So that will equal to 0.001028 into 10 power 3 mole per, okay. So in 1 milliliter, that will be 10 power minus 3 mole per milliliter. In 1 milliliter, number of moles of electrolyte will be less. So that much will be there. So that's why lambda m has been taken K by C. So kappa by C. So that's why this will be get multiplied by divided by 1000. So that is, and alpha is lambda m upon lambda degree m. So Ka. Clear here or not? If not, then watch out by the another method. Acetic acid. That will dissociate to acetate ion and H plus ion. Concentration here this much. So lambda m will be equal to K by C, kappa by C. Kappa has been given 4.95. This much. So 4.95 into 10 power minus 5 Simon per centimeter. Concentration you will have to take in here. This one in 1 milliliter divided by 1000. So 0.001028. That much mole per liter you have there is. So that much divide by mole per milliliter, that will be when you will divide by 1000. Kappa by C lambda m is that much. So main division line is this much. That means that will equal to 4.95 into 10 power minus 5 Simon per centimeter into 1000 into 1000, that upon 0.001028 mole per milliliter, that means per centimeter cube. Okay, calculate this one, you will get the molar conductivity, that will become 48.15. that much Simon here. So Simon centimeter square per mole. Clear? Then after is alpha. For this one concentration is C, so it will be 0. Now at equilibrium, what is will be here? C into 1 minus alpha. House I have taught you also. It will be C alpha, it will be C alpha. C alpha into C alpha. Ka will be equal to C alpha into C alpha on into C into 1 minus alpha. C cancel out. That will be equal to C alpha square upon 1 minus alpha. Put the value of alpha as, so here alpha is lambda m upon lambda degree m. That's whole square, that upon 1 minus lambda m upon lambda degree m. This much. Put the value, you will calculate, and finally the answer will come 1.78 into 10 power minus 5 mole per liter. Okay, Ka will be that much. Okay guys, Now let's see, proceed on that one. Next. What does conductivity? Watch out this question. Very easy it is to calculate this one. Watch out. Why does the conductivity of a solution decreases with addition? So conductivity decreases because number of ions per unit volume will decrease. Second one is suggest a way to determine lambda em value for water. For water, that means water will be here. How to calculate? So water is not a strong electrolyte. So lambda degree m for water, that will be equal to lambda degree m for H plus and lambda degree m for OH minus. So from acetic acid, so that means lambda degree m for with the help of HCl and with the help of NaOH, and like that to other strong electrolyte. By taking this one, you can calculate the lambda degree m of water. Okay, try this one by yourself. It's not difficult. This topic is too much easy. Even though if you would feel any difficulty, then ask from me. Ask in the comment box. I shall reply about that. Okay. Then after is electrolytic cells and electrolysis. Okay. Very important question. Very important topic of this chapter, that is electrolytic cells and electrolysis. About the electrolytic cells and electrolysis, what is here electrolysis? What that is? If in a cell here, in a galvanic cell, what was happening there? Here was cathode, and here is, suppose here, the anode, zinc rod here, and here copper rod. If it is copper rod, when you connect both the electrodes, then electron will flow from zinc rod to copper rod, like this one. Or if you separate in the separate vessels, like this one, here zinc electrode, here another vessel, here copper electrode, both connected through the salt bridge. Recall the initial topic of this chapter, and both the electrode has been connected through the wires, here voltmeter and this one. So what happened here during this course? Electron will flow in this direction, so current will flow in this direction. But your voltmeter, same here, electron flow in this direction and current will flow in this direction. In this direction, current will flow in this direction, electron will flow in this direction. That means electron will flow from zinc to the copper, and the current will flow from, direction of current will be from copper to the zinc electrode through the salt bridge. That means an ion will come inside this vessel. You have already studied in the initial topic of this chapter. Now what to do when this vessel here now this same zinc rod This is another, when there was a connector through the voltmeter, then electron was flowing in this direction, current was flowing in this direction. But what happened when you have connected this zinc rod through the negative side of a battery and the copper rod through the positive side of a battery? Then what happened? Electron will start flowing in this direction. So as at this rod, this zinc rod will become full of electron. When you have connected the negative end of a battery to the zinc electrode and the positive end of a battery to the copper electrode, then electron will come at the zinc rod. What will happen here during that course? The Zn2 plus ion, which is present inside the solution, that will get attracted towards this side, and then after this Zn2 plus, this Zn2 plus will take 2 electron and convert into zinc atom. So zinc ion initially was in aqueous state, and zinc here, that will come in the atomic state. So zinc will get deposit. What was happening in galvanic cell? The zinc ion was entering inside the solution. But in case of electrolytic cell, the zinc ion present inside the solution, that will get attracted towards the zinc rod and will gain the electron. Initially in galvanic cell, the zinc was losing the electron. In case of electrolytic cell, the zinc ion will gain the electron. So reaction here is reverse. Same here, when electron here, that has been attached to the positive end. So what happens here? The copper atom present at this one here is positive side. So how the positive will get? So this positive end of the battery will take the electron of this copper rod. So when electron will go from there, so from copper there will be loss of 2 electron. So there will be formation of copper ion. Electron gone to this side, so copper ion will enter inside the solution. In galvanic cell, what was happening? In galvanic cell, Cu2 plus was depositing at the rod. But in case of electrolytic cell, the Cu atom, the copper atom, will lose the electron, will convert it into Cu2 plus and will enter inside the solution. This one. Okay, so that is electrolytic cell. So in case of electrolytic cell, the opposite things happen here. That means the process becomes here reverse. The reverse process takes place in electrolytic cell than that of the galvanic cell. Okay, now here this rod, zinc rod here, that will act as cathode, and here copper rod, that will be called anode. Towards which side? Cation will get deposited, that will be called cathode. Okay, in the previous case in galvanic cell, cathode was depositing at the, that means Cu2 plus was depositing at the copper rod. So in the case of galvanic cell in which the zinc and copper was taken, the copper rod was acting as cathode because cation was depositing at the copper rod. Cation were depositing at the copper rod. That's why in the galvanic cell, the copper rod was acting as cathode. In electrolytic cell here, same material we have taken of zinc and copper electrode, but the cation is depositing at the zinc rod. That's why in this case, the zinc rod will act as cathode. Okay, now let's see. Whenever we will have to discuss about electrolytic cells and electrolysis, then we will have to consider about Faraday's law of electrolysis. Then Faraday's laws of electrolysis we should keep in our mind. So Faraday's first law of electricity, Faraday's first law of electrolysis, very simple it is. Faraday's first law of electrolysis says that the how much charge we will pass through the solution. If we will pass more amount of charge, then more amount of cation will deposit or will comes out from the electrode. That means here the Faraday's law states that amount of chemical reaction that will be directly proportional to amount of charge passes through the solution. So what's here written here? The amount of chemical reaction, the amount of chemical reactions which occurs at a current is proportional to the, okay, so that is here. So at their respective electrode, what's the chemical reaction will take place? Chemical reaction here is losing of electron or gaining of electron. So what will be the amount of chemical reactions? That will be directly proportional to the charge passes through the solution. Okay. Now second law of electrolysis says that, suppose here, what is that? That means second law of electrolysis says that the amount of, if same quantity of electricity is passing through the electrode, if same quantity of electricity is passing through different electrodes, then the amount of electrolyte get deposited or released, that will be directly proportional to the equivalent weight of that substance. That means how much, if same quantity of electricity will pass through different solutions, then the same number of gram equivalent of the substance will deposit at their respective electrode. What is gram equivalent or what is equivalent weight? Let's see here. Same here, whenever you will have to find out the equivalent weight, so you will have to consider about charge like Cu2 plus. So suppose firstly Ca2 plus, Cu 63 atomic weight. Here same, you can also take of the Cu2 plus. So molecular weight of copper is how much? 63 gram per mole. Already know. So equivalent weight will be how much? Charge is here plus 2, Cu2 plus. So equivalent weight of Cu2 plus, charge is 2, so that's why 63 upon 2, that much gram per mole, that will be equivalent will be per ion, you may write. Same here, calcium ion Ca2 plus. So molecular weight of calcium, you know already, 40. So equivalent weight of calcium will be how much? So molecular weight is this much, charge is here 2, so that is 40 upon 2, that is 20. If you will have to find out the molecular weight of equivalent weight of suppose sulfate, so SO4 2 minus, so equivalent weight of SO4 2 minus, that will equal to here. So find their molar mass, sulfate 32 plus that upon 2 will be there, sulfate ion, that is equivalent weight. Okay, and number of gram equivalent, keep in the mind, if that will be more important for the main examination who are studying, and about that we will prepare for the main examination. We will also, I shall discuss about this topic again for the videos of NEET examination and of IIT, which will be combined way. Separately, I shall not make the separate videos for the NEET examination and for the IIT main, and for yes, for the IIT advanced I shall make a separate video, but there will be a combined videos for IIT main as well as for NEET examination, and there I shall only emphasize that which particular question is more important for IIT main and which question is more important for NEET examination. Let's see firstly here. So number of gram equivalent, that is equal to here total weight that upon equivalent weight. As the number of moles you have studied, number of moles that you have calculated, total weight that upon molecular weight, molecular weight, or in case of molecule, molecular weight, in case of atoms, atomic weight, in case of ions, ionic weight. So that is here. So Faraday's first law states that when the quantity of electrolyte get deposited at the cation or the quantity of charges released out from the anion, that will be directly proportional to the amount of charge passing through the solution. If we will pass more amount of charge, then more amount of cation will deposit at the cathode, or more number of cation will coming out from the anode. Okay, Faraday's first law states that the reactions taking at the respective electrode will be directly proportional to the quantity of electricity or quantity of charge passing through the solution. And the Faraday's second law states that when same quantity of charges passing through two solutions, so then same number of gram equivalent of electrolyte will get deposited or will release from the solution. When same charges passing through the two different solutions, then same number of gram equivalent of cation will deposit at the cathode, or cation will get released out from the anode. Okay, if that means here this one given the amount of different. Okay, this point here. Based on that, we will discuss about this question, and there is 2-3 questions there, in particular 2 questions in the exercise which has been asked in NEET examination and in IIT examination a number of times. We will discuss about those type of questions in the next video. Today it's all for this video. Thank you, Team Educate.